Hello everybody, my name is Asko Ristolainen and I'm from Tallinn University of Technology from the Center for Biorobotics. And in today's presentation, I will talk about the usage of novel flow sensors in measuring distributed flows in aquaculture sea cages. So shortly about our team. The Center for Biorobotics is now just over 10 years old, and as the name says, we're dealing with different bio-inspired robots. But also, we are building different sensors that are inspired by nature, and we are applying them in different aquatic environments. The challenges that we are trying to solve with our new devices is to understand what is happening in sea cages in currents, and more specifically, what is happening in sea cages when the flows go through the sea cages. It is known that freshwater movement affects the amount of oxygen that is available for the fishes in sea cages, but also the currents affect the movement of waste and food. So in this study, we're trying to understand what is happening inside sea cages at different depths. As a solution, we propose to use novel flow sensors called the hydromast in a suspended array. We used these devices at SINTEF facilities on the island of Froya. Those devices are point measuring devices that we placed at 5, 10 and 15 meters to measure distributed flows. We used on-site power to power the devices, and logging electronics was hooked up through the GSM network also to our server, so we could monitor the devices online. The benefits of using the array of sensors is that we can monitor the changes of flows in real time. We can also see when the actual maintenance on the sea cages must be done and if there is enough flow going through the sea cages at any moment of time. And secondly, the point measurement devices, the hydromasts, are not affected by shadowing effects like other acoustic measurement devices are. So therefore they can be placed, for example, between the fishes without any problems. When we look at the device itself, then on the left image you can see that the hydromast has a vibrating mast that, when placed inside a water flow, starts vibrating. By measuring the vibrations and the frequencies of this mast, we can tell how strong the current is. The device also has an internal measurement unit inside the hydromast casing that we use to remove the background vibrations from the measurements. And we use the fin and compass to understand where the flow is coming from. And on the right image you can see that the device is rather small. It can fit into your palm, and the device includes also internal logging possibilities, so they can be used as standalone devices also. Looking at the target markets, then in this study we used the devices in fish farms, but we have been also investigating the possibility to measure the currents on the bottom of the sea in algae farms to see how the plants are affected by the sea currents. Also, we have an installation here in one of the harbors in Estonia where we measure the currents inside the harbor to help ship captains and harbor captains to dock their ships more safely. And in the initial studies, we used the hydromasts to monitor different flow regimes in rivers to map different habitats in different spots in rivers. And if you look at the applications of the hydromasts, then of course one of them is the situational awareness, but the hydromasts can be also used for possible site investigations before actual fish farming nets are placed in open seas. We can use the devices to evaluate the effects of climate extremes. For example, what happens in storms, surges to the fish cages. And of course, we can monitor long-term changes in flow regimes through the nets. So I think the key point is the situational awareness still. When we look at the economic impacts that hydromasts in suspended arrays can have in fish farming, then they can help to improve the health of the environment of the sea cages. Then also the array of sensors can help to improve the situational awareness in real time, as it's possible to see what's happening online with the flow. And thirdly, the changes in the flows over time can also tell us when we need to inspect the cages for their cleanness. The competitors of our devices are ADVs and ADCPs. They are about 1 magnitude more expensive than our devices. And secondly, the restrictions of using ADVs and ADCPs is that they cannot see through the nets, so therefore they need to be inside the cages. And secondly, the fishes swimming underneath or over the sensors can affect the measurements of these acoustic devices. At the moment, our devices are at TRL level 4 and 5, meaning that we have been testing the hydromasts now in the relevant environments. The technology itself is patented and the IP belongs to the university. What we are looking from the industry is to have longer pilot studies to help us to improve the technology further. So we're looking at fish farms that have similar problems with sea cages where we could measure distributed flows. Thank you for your attention. Please feel free to contact me directly to find out more about the hydromast and its applications. And if you would like to use the devices and help us to improve the technology, I'm happy to answer your questions. So thank you for your attention.